Look at Earth. We call it the blue planet, an endless, life-giving expanse of oceans. But honestly, that is a brilliant cosmic illusion. From our tiny perspective on the surface, the Pacific Ocean seems infinite. It covers over 70% of our globe, hiding unimaginable depths. But let's step back and look at the big picture. As an astronomical body, Earth is essentially a giant ball of rock and metal. What if we could take a cosmic sponge and soak up every single drop of water on Earth? Oceans, ice caps, clouds, everything. Let's extract all that water, lifting it off the crust, and roll it into a single, perfectly spherical floating droplet in space. According to data from the U.S. Geological Survey, all the water on Earth adds up to about 1.3 billion cubic kilometers. That sounds massive until you see it next to Earth. This sphere of water would only be about 1,380 kilometers wide. To put that in perspective, this entire sphere of Earth's water is significantly smaller than our own moon. It's just a tiny cosmic puddle. Our penguin astronaut friend here looks disappointed, right? The mighty blue planet suddenly looks more like a slightly damp piece of gravel. The reality is, our oceans are incredibly shallow compared to the planet's massive diameter. It is just a microscopic film resting on the surface. If the Earth were the size of a standard apple, the entire global ocean would be thinner than the skin of that very apple. So, by cosmic standards, Earth isn't a water world at all. It is a dry, rocky desert that just happens to have a wet surface. If Earth is a desert, then where is the real water in our solar system? Where are the true, unfathomably deep oceans hiding? To find them, we have to leave the warm, comfortable inner solar system behind and journey outward into the freezing, mysterious darkness. We must cross an ancient boundary known as the frost line, heading toward the giant planets, where water isn't just a surface layer, it's everything. To understand why the outer solar system hoards so much water, we have to rewind the clock 4.6 billion years. When our young sun ignited, it released ferocious solar winds. This blast of energy pushed lighter molecules, like water vapor, far away from the center. In this inner zone, it was simply too hot. Any water that tried to condense would instantly vaporize. So, early Earth formed as a bone-dry, molten rock. But if you traveled outward, away from the sun's blistering heat, you would eventually hit a critical boundary, the frost line, located at about 5 astronomical units. In the vacuum of space, temperature behaves differently. Beyond this line, it was cold enough for water vapor to instantly sublimate into solid ice. Trillions of tons of water vapor crystallized into microscopic snowflakes, creating a massive cosmic blizzard in the outer solar system. Over millions of years, these ice crystals clumped together with rock and dust. Because there was so much ice, the planetary bodies out here grew massive. They became the cores of the gas giants, Jupiter and Saturn, and formed their extensive families of icy moons, the ultimate water vaults of the solar system. While the inner planets were starved of moisture, these outer moons were constructed with up to 50% pure water ice by mass. Which raises a massive question. If Earth formed completely dry, inside the frost line, how did we get any oceans at all? The leading theory is the late heavy bombardment. Millions of years after Earth formed, the gravity of the giant planet shifted, sending icy comets and asteroids hurling inward. These frozen delivery trucks smashed into the dry Earth. Upon impact, the ice melted and vaporized, eventually raining down for millennia to fill our basins. So, Earth's mighty oceans are essentially just the melted scraps. We got the leftovers of a chaotic cosmic billiard game. Earth only received a tiny splash. But out here, Jupiter's moons kept their entire, colossal icy inheritance. And beneath the frozen shell of one particular moon, a combination of physics and gravity has kept that ancient water liquid to this very day. Welcome to Europa. From the outside, Europa looks like a dead, frozen wasteland. Its surface temperature never rises above -160 degrees Celsius. At a glance, water shouldn't exist here in a liquid state. It should be solid ice all the way down to the core. But in the late 1990s, NASA's Galileo spacecraft flew by this enigmatic moon, and its instruments detected something impossible. Galileo's magnetometer measured a strange disruption in Jupiter's magnetic field around Europa. The only logical explanation? A massive, electrically conductive fluid beneath the crust. A global, salty, liquid water ocean, hidden in plain sight. How does it stay liquid? The
The
answer lies in a brutal
Yes, the
gravitational
tidal
tug-of-war
stress
known
at
as tidal
periapsis is
heating.
exactly what the
Europa's orbit isn't a perfect circle, it's elliptical. As it moves closer to Jupiter, the giant planet's immense gravity literally stretches the entire moon. When it moves further away, the moon relaxes. This constant squeezing and stretching creates immense internal friction deep within Europa's rocky core. That heat radiates upward, melting the inside of the ice shell. It's essentially a planetary-scale internal heating system powered by gravity. Based on structural modeling and spacecraft data, we've mapped out Europa's anatomy. And the scale is simply terrifying. The outer frozen shell that we see is estimated to be anywhere from 15 to 25 kilometers thick, harder than granite. But beneath that lies the abyssal ocean. This pitch-black, global sea is believed to be 60 to 150 kilometers deep. For comparison, the deepest part of Earth's ocean, the Mariana Trench, is barely 11 kilometers deep. Europa's ocean dwarfs it entirely. If you were dropped into this abyss, it would take you hours just to sink to the bottom. It is a volume of water so vast that it fundamentally redefines what a water world actually is. Let's do the ultimate math. Let's compare Europa to Earth side by side. Side by side, it doesn't seem like a fair fight. Earth is nearly 4 times larger in diameter than Europa. Earlier, we took all the water on Earth and rolled it into a sphere about 1,380 kilometers wide. Now, let's do the exact same thing to Europa. First, we strip away its thick, frozen outer shell. Then, we extract that incredibly deep, global subsurface ocean, peeling it off the moon's rocky core. And we roll it into a single sphere. And it just keeps growing and growing. Europa's hidden ocean contains roughly 3 billion cubic kilometers of liquid water. Bring back Earth's water sphere, and the reality of the solar system hits you like a tidal wave. That tiny speck orbiting Jupiter holds more than twice the amount of liquid water than our entire blue planet. It's an absolutely humbling perspective. We are not the kings of the cosmic ocean. We're just splashing in a puddle. When you strip away the rock and ice, you realize that Europa is, proportionally, a true water world. And where there is stable, liquid water, our minds immediately jump to the biggest question in science. Could there be life? Europa has more than double the habitable real estate of Earth. But incredibly, it doesn't even hold the record for the most water. If we look slightly further out in Jupiter's orbit, we find a moon so massive it has its own magnetic field. This is Ganymede, the largest moon in the solar system, bigger than the planet Mercury. And its water reserves? They break the scale completely. Ganymede doesn't just have one ocean. It might be hiding a massive, cosmic club sandwich of ice and water. In 2015, data from the Hubble Space Telescope allowed scientists to finally peer inside the giant moon, revealing an interior unlike anything else. Unlike Europa, Ganymede is so massive that the gravitational pressure near its rocky core is absolutely incomprehensible. On Earth, ice is less dense than water, which is why it floats. But under Ganymede's extreme pressure, water molecules are literally crushed into exotic forms of solid ice known as Ice 6 and Ice 7. These frozen layers are heavier than liquid water, so they sink. This creates a bizarre internal structure: a layer of surface ice, a layer of water, heavy sinking ice, more water, even heavier ice. It is, quite literally, a planetary-scale club sandwich of oceans and ice. Hubble proved this existed by observing Ganymede's auroras. Yes, this moon has its own magnetic field, generating glowing lights at its poles. The auroras were rocking less than they should have been. Why? Because a massive, underground saltwater ocean was creating friction, resisting Jupiter's magnetic pull. So we know the water is there. It's time for the final extraction. Let's pull the water out of Ganymede's massive sandwich. We extract the surface ocean, then the deep ocean, then the abyssal ocean hidden beneath the heavy ice. And we roll it all into a single, terrifyingly large sphere of pure water. The estimated total volume? 35 billion cubic kilometers of water. If we put Earth's entire water supply next to it, Ganymede contains 26 times more water than our entire planet. The blue planet is definitively dethroned. Jupiter is the true king of the water worlds. But Jupiter's ocean moons are locked under kilometers of solid ice. If we want to find an ocean that is actively spraying out into space, we have to travel even further. 1 billion kilometers further into the freezing darkness, we arrive at the absolute jewel of our solar system, Saturn. Amidst its spectacular rings orbits a tiny, incredibly bright moon. This is Enceladus. Unlike the behemoths of Jupiter, Enceladus is tiny. At barely 500 kilometers across, it could comfortably fit inside the borders of the United Kingdom. Because its surface is made of fresh, pristine ice, it is one of the most reflective and coldest objects in the entire solar system. But in 2005, the Cassini spacecraft pointed its cameras at the moon's south pole and discovered massive, glowing blue fractures. Scientists named them the tiger stripes. But these are not just dead geological scars. They are active, roaring wounds. From these massive canyons, the moon is violently erupting. But this isn't a volcano of fire and magma. It is a cryovolcano, a cosmic snow cannon, shooting subsurface ocean water directly into space. The water blasts out at terrifying speeds, exceeding 400 meters per second. That's over 1,400 kilometers per hour. The pressure from the hidden ocean beneath is so intense, it simply tears the crust apart to vent the strain. Because Enceladus is so incredibly small, its gravity is very weak. Most of this water never falls back down as snow. It reaches escape velocity. Over billions of years, this tiny moon has been single-handedly spraying a massive torus of ice around the giant planet, creating Saturn's majestic E-ring. This was a scientific goldmine. We didn't have to drill through 20 kilometers of ice to taste an alien ocean. Enceladus was serving it up to us on a silver platter. NASA made a daring decision: fly the Cassini spacecraft directly through the erupting plumes at high speed and analyze the water. What the mass spectrometer found hidden inside those tiny, frozen droplets would alter the course of human history. When the data from the plume finally reached Earth, scientists were stunned. It wasn't just water. It was a complex chemical cocktail. Cassini detected methane, ammonia, and carbon dioxide. Basic, simple compounds. But in 2018, researchers found something much heavier in the data. Macromolecular organics. Massive, complex carbon chains weighing hundreds of atomic mass units. In astrobiology, these are the fundamental building blocks of life. They are the chemical precursors to amino acids and proteins. Enceladus doesn't just have water. It has a thick, rich primordial soup, perfectly mixed and ready to go. But to ignite the spark of life, soup isn't enough. You need an energy source, a battery to drive the chemical reactions. Out here, sunlight is incredibly weak. And beneath 40 kilometers of solid ice, the ocean is locked in absolute, eternal darkness. Photosynthesis is impossible. But Cassini found one more crucial clue in the plume: microscopic grains of silica sand. On Earth, these specific silica nanoparticles only form in one very specific environment, where liquid water meets scalding hot rock. This means that at the very bottom of Enceladus' abyssal ocean, the seafloor is torn open, releasing intense geothermal heat. These are hydrothermal vents. They spew scalding, mineral-rich water into the freezing ocean, creating a massive chemical energy gradient. On Earth, similar vents at the bottom of the Mariana Trench are completely disconnected from the sun, yet they are teeming with bizarre alien-like ecosystems. Enceladus has the water. It has the organic building blocks. And it has the geothermal engine to power it all. For the first time in human history, we have found a place off Earth that possesses every single ingredient required for life as we know it. This completely shifts our perspective. We are no longer just looking for water. We are looking for a second Genesis. But before we leave the Saturnian system, there is one more world we must visit. A bizarre, twisted reflection of our own Earth. Meet Titan. It is the only moon in the entire solar system with a dense atmosphere. In fact, its air is 50% thicker than Earth's. In 2005, the Huygens probe parachuted through this impenetrable orange smog. What it captured on the way down shocked astronomers. Beneath the clouds lies a shockingly familiar landscape. There are towering mountains, winding river valleys, and massive, shimmering lakes. But at minus 179 degrees Celsius, this is not a water world. Those lakes are filled with liquid methane and ethane. At these extreme temperatures, water is completely frozen solid. On Titan, water ice doesn't melt. It acts as the planetary bedrock, as hard as Earth's granite. Titan has a complete, functioning weather system. Instead of a water cycle, it has a methane cycle. It evaporates, forms clouds, and literally rains down. It is the only other place in the known universe where you could stand on a solid surface and watch liquid rain fall from the sky. This presents a mind-bending question for astrobiologists. Could a completely bizarre, alien form of life evolve in liquid methane instead of water? Perhaps. But Titan has one final, staggering secret. It doesn't just have liquid methane on the outside. Just like Europa and Ganymede, Titan hides a massive, global liquid water ocean deep beneath its icy crust. Because Titan is so incredibly large, the second largest moon in the solar system, the absolute volume of this hidden water is astronomical. If we run our simulation again, extracting Titan's deep water and rolling it into a single sphere in space, it eclipses Earth's total water volume by over 11 times. Another crushing defeat for the blue planet. When you look at the raw data, the truth is undeniable. The inner solar system is a dry desert. The outer solar system is the true cosmic ocean. But having an ocean doesn't guarantee life. To understand how life could actually survive in these dark abysses, we have to look back at Earth. In the year 2000, scientists exploring the Mid-Atlantic Ridge on Earth discovered a bizarre underwater structure they named the Lost City. Unlike the violent, black smoke vents we usually see, the Lost City features towering, ghostly white chimneys venting highly alkaline fluids. Down here, there is zero sunlight. Photosynthesis is impossible. Instead, the ecosystem survives on chemosynthesis. Microbes eat the invisible chemicals dissolved in the vent water, like hydrogen and methane, and convert them directly into biological energy. If we apply this exact blueprint to Europa, the implications are staggering. Let's dive 100 kilometers down to Europa's seafloor. Down here, the pressure is immense. It is pitch black. But thanks to Jupiter's immense tidal heating, the rocky seafloor is physically tearing apart, just like on Earth, creating massive, alien hydrothermal vent fields. As the seawater interacts with the hot, iron-rich mantle rock, a chemical reaction called serpentinization occurs, releasing pure hydrogen. This creates the ultimate battery. You have scalding hot, chemical-rich fluid mixing instantly with freezing cold seawater. And here is the most crucial fact. Europa's ocean has likely existed in this exact, stable state for over 4 billion years. Plenty of time for life to emerge. What kind of life could be swimming in that dark water right now? It could just be simple, single-celled bacteria clinging to the rocks. Or, given billions of years of undisturbed evolution, it could be something much larger, complex, bioluminescent predators hunting in the pitch black. If we ever break through the ice and send a submarine down there, what will stare back at us? For now, Europa keeps its secret sealed perfectly beneath 20 kilometers of impenetrable ice. But humanity is not content with just staring at a locked vault. Right now, a key is speeding through the dark void of space. Launched in 2024, NASA's Europa Clipper will arrive in 2030. It won't land, but it will use powerful ice-penetrating radar to peer deep into the abyss. If Clipper finds pockets of liquid water near the surface, or signs of habitability, it forces us to confront the ultimate philosophical question. If we find life there, how did it start? One theory is panspermia. Asteroid impacts on Earth could have blasted microbes into space, eventually landing on Europa. If that's true, they are our cosmic cousins. But what if their biochemistry is entirely different? What if they don't use DNA at all? That would mean life didn't just spread. It started completely from scratch, twice, in the exact same solar system. A second genesis. If the spark of life can ignite twice around a single, average yellow star, then it means the universe is not a sterile, dead void. It means the cosmos is a teeming, overflowing ocean of life. Out there, right now, under the ice of trillions of unknown exoplanets, alien oceans are waiting in the dark. We began this journey by stripping Earth of its title. We proved that it is dwarfed by the massive water worlds of the outer solar system. But as we return that tiny, seemingly insignificant sphere of water back to the dry crust of our home, we realize exactly what makes Earth so incredibly special. It's not the amount of water we have. It's the fact that our water is on the surface, basking in the sunlight, allowing us to exist, to build telescopes, and to look up at the dark, icy vaults of our cosmic neighbors. Until we drill through the ice of Europa or Enceladus, Earth remains the only confirmed spark in the dark. Thanks for exploring with us. If you want to dive into more cosmic mysteries, hit subscribe, and I'll see you in the next orbit.